Hi, a warm welcome to you. In the last video, we have seen polynomials, definition, types of polynomials, and how to do arithmetic operations on polynomials like addition, subtraction, multiplication, and we are going through the division. So, we'll continue with the division in this video, and also we'll go through the remainder theorem. So, to go ahead with the polynomials division, let's step a little bit back and try to understand how we have done in childhood the division of two numbers. Let us say that I want to divide 14 with 3. So what we used to do is 3 table 4 times, I get 12, so the remainder is 2. So then we used to write dividend. This is what we have learned in childhood. Dividend is equal to divisor into quotient plus remainder. So we say 14 is equal to 3 into 4 plus 2. This is how we have learned that if we divide 14 by 3, you will get 4 as your quotient and 2 as your remainder. Now let's take a simple example. Let's take a simple example of polynomials and see how we will do that. Let us say one polynomial is x cube plus x square plus 7x. You want to divide this polynomial with x. Let us see how this goes. We know that if I am dividing, I have to divide the each term. That's nothing but x cube plus x square plus 7x by whole x. I can say it as by x and by x. This is nothing but equal to x square plus x plus 7. So we can go ahead and write x cube plus x square plus 7x is equal to x into x square plus x plus 7 plus 0. And you can compare this with what we have written here. Dividend is equal to divisor into quotient plus remainder. Here the division is appropriate. We don't have any remainder, that's why it's 0. But please look at the way how we can do. As we are doing the numbers, we should be able to do it for the polynomials also. So it's very simple. If it is a monomial and have only one variable, that's or it's a constant, it's fine. But if you have a binomial and you have to divide, then how to do that? We'll look into that division and see how we will move forward with that. Now let's take a simple example. Suppose I have one polynomial as x square minus 5x plus 7, and that I have to divide with x minus 1. So to do this, how you have to do it? Let me try to explain you step by step. X square minus 5x plus 7 is our dividend and x minus 1 is the divisor. So first step what we have to do, here what we see for 14, we see in third table when we will get the term near to 14. 3 4s are 12, 3 5s are 15. So we go for 3 4. Here what you have to do is, you have to look at the first terms of, or I should say highest, or the degrees of this polynomial. Here the degree is 2, here the degree is 1. So if we try to divide that, term by term, x square by x. This is nothing but the highest degree term of the dividend divided by highest degree term of the divisor. You get x. So what I will do, I will say that if idea is if I multiply with x minus 1, then I should be able to cancel out x square term. So I will left only with the x terms. So I will say here x. Now what will happen? X into x is x square. That is fine. X into minus 1 is minus x. So now I have to subtract as you do for general division. So this becomes minus, this minus plus. So minus 5x plus x is minus 4x, and I brought forward 7. Now again let's go back and see here in this particular term what is the degree and what is the term having the highest, that is minus 4x, and here x. So I will divide by minus 4x by x, that is minus 4. So I will put here minus 4 and I will calculate minus 4 with the divisor. So it is minus 4 into x minus of minus plus 4. So if I subtract, this will become plus, this will become minus. So I will left out with the remainder of 3. This is quotient, this is the divisor, and this is the dividend. So this is nothing but equal to, writing something like 14 equal to 3 into 4 plus 2. We are saying x square minus 5x plus 7 is equal to x minus 1 into x minus 4 plus 3. This is nothing but equal to, exactly equal to, dividend equal to divisor into quotient plus remainder. This is how we will be doing this division, which is called as long division. How we do? Let me repeat again. Look at the term which is having highest degree in divisor, and remember you have to put it in the descending order, both of them. You have to put both dividend and divisor in the descending order from the degree. That means here the degree is 2, so I will have next to, I will have term with having degree 1, then I will have 0. Similarly here x minus 1. Now I will divide the highest term with the highest term here, that is x square by x. I got x. So I'll put x as the first term of the quotient and I multiply with x. Then I'll cancel it out. Then I see that I have minus 4x plus 7 here and x here. So both of the degrees are equal. If I divide minus 4x by x, I get minus 4. So I put minus 4 here and I multiply with x minus 1. Then I cancel it out to get the remainder. So now you can see that I can write x square minus 5x plus 7 equal to x minus 1 into x minus 4 plus 3. Now let us say that you have to divide a polynomial which is very complex and you have to divide with a linear polynomial. Then you are not interested to find out what is the quotient, but you are interested in finding out the remainder. So in such cases, this process may be a little bit tedious. To explore, is there any other alternative? Let us do this. Let us say, suppose we have seen here that x square minus 5x plus 7, I can write it as x minus 1 into x minus 4 plus 3. So let us say p of one value we want to calculate. That means in x square minus 5x plus 7, I want to substitute the value of 1. That's nothing but equal to 1 square minus 5 into 1 plus 7, that is 1 minus 5 plus 7 equal to 3. Similarly, let me also try for the value of p of 4 and see what happens. So I have here 4 square x square minus 5 into x, that is 4, plus 7, that is nothing but 16, minus 20 plus 7 equal to 3. So instead of doing the whole long division method, we see that if you want to divide a polynomial with x minus 1, then you just go ahead and put in the polynomial the value of x equal to 1, or nothing but since this is x minus a, put the value of a. So this is nothing but called as remainder theorem. So let's go ahead and see what is remainder theorem. Just before going there, what I am saying is we are trying to divide this number by this number, x square minus 5x plus 7 by x minus 1. We got the remainder as 3. We also observed that in the polynomial, if I keep the value of x minus 1 equal to 0, x equal to 1, if I substitute the value of 1, then I see that the remainder is again 3. That means if I want to divide this polynomial with x minus 1, I'm not interested in finding out the quotient, I'm just interested in finding out the remainder. Then, instead of doing the long division method, which may become tedious in some occasions, I can directly go forward and substitute the value of 1 in the polynomial to get the remainder, which gives an interesting theorem called the remainder theorem. Let's go ahead and see what is remainder theorem. Remainder theorem states that let Px be any polynomial of degree greater than or equal to 1, and let a be the real number. If Px is divided by the linear polynomial x minus a, then the remainder is P of a. What's the meaning of that? Is it says that P of x is equal to some value quotient g of x into x minus a plus remainder. Remainder is nothing but equal to P of a. So this is what remainder theorem says, that remainder theorem says that if you are dividing P of x with the linear polynomial x minus a, then the remainder is P of a. We can check that very easily. Let's go ahead and check that. Let us say that we are dividing this by x minus a. So you can see that if I dividing this by x minus a, then the theorem states that the remainder is equal to P of a. So instead of going through the long division method and finding out the remainder, which we have done here, is simple example, but we can take more complicated example. You can directly find out the remainder by substituting the value of a directly in that. You can cross check here. Suppose you put x equal to a, this becomes P of a is equal to x minus a becomes 0. So you get again P of a. So this is about the remainder theorem. Let's take a simple example and see how we can do the remainder theorem. Take a simple example to understand about the remainder theorem. Let me just try to erase this so that we can go ahead with the example. Let us take a division and also check with the remainder theorem whether it satisfies or not. Let me take a number. Let me take two polynomials. I have two polynomials here. I am trying to divide one with a linear polynomial. Let us say x minus 2 and the polynomial is 2x cube plus 3x square minus 11x minus 2. So this I want to divide. Now we want to find out the remainder. The remainder theorem says that you can directly go ahead with P of 2, substitute the value 2 into 2 cube plus 3 into 2 square minus 11 into 2 minus 2 should be your remainder. Even you do the long division method, you should get the same thing. Let's simplify this and see what is the value of that. 2 cube is 8, 8 2s are 16, plus 2 square is 4, 4 3s are 12, minus 2 11s are 22, minus 2. This is 28 minus 22, 6, 6 minus 2, 4. The remainder is 4. Let's try to check with the long division and see whether we are getting the same result or not. Now how we will proceed? We will proceed first putting them in the descending order, which I have done already. I have degree 3, 2, 1 constant. Similarly here I have degree 1 and then constant. Now if I divide 2x cube by x, my first statement, first thing what I have to do is I have to divide 2x cube by x. It gives me 2x square. So my first term in the quotient will be 2x square. 2x square into x is 2x cube. Now I have to multiply the second term also, that is nothing but minus 4x square. Now I will subtract this. The idea is to cancel this out. So now I got 7x square minus 11x. Again I have x square, 7x square here and x here. So I will divide 7x square by x. I see that the value is 7x. So I'll put 7x here. 7x into x is 7x square. Then 7x into minus 2 is equal to minus 14x. Now again I subtract. I get the value of 3x minus 2. Now I see that 3x by x is 3. So I'll put here 3. 3 into x is 3x minus 6. If I subtract, I get the value of 4, which we have found very easily by substituting the value. So that's about the remainder theorem and the division. This is called long division method. Whatever we have learned, instead of doing the long division method, we can find out the remainder by just substituting. If we are dividing a polynomial of degree greater than or equal to 1 by a linear polynomial x minus a, then the remainder is nothing but equal to p of a, or simply the substitution of value x equal to a in the polynomial to get the remainder. So that's how we have seen remainder theorem, and also we have checked with one example whether the remainder theorem is working out properly or not. In the next video, we will see factor theorem and how to find out the factors of polynomials. Thanks for visiting. Bye for now. See you in the next video.